Welcome back to another day of algebra. Hope everything's going okay and you're not missing me too badly, but I'll be back soon. Today we're going to learn two concepts. We're going to learn concept number 8, function notation, and concept number 9, domain and range. Both of these concepts are actually pretty straightforward, so I think you won't have any problem with them whatsoever. So what I would like you to do right now is I want you to complete the problems that you see here right now on your own. So I want you to stop the video, actually stop the video, and don't tune back in until you've completed these problems. So welcome back. For the first 4 problems, you should have gotten 93, 29, 93, and -6. If you didn't get that, go ahead and take a look at my work. I just want to point out one more time that whenever you are plugging a negative number in for a variable that's squared, don't forget to put those parentheses around it, okay? So I did it here, and I did it here. You also have to do it with fractions as well. I don't think I mentioned that the other day. But anyway, if you take your problem straight from here to this line, that's totally fine. A lot of you might have even been able to do some of these in your head as well. Just make sure that you did them right. Now, the table I haven't filled in yet because I figured some of you might be confused by that. So all I meant by was putting your stuff in the table. If you notice, all of the values that we put into this expression were called x. So I'm just going to go ahead and put an x here, and we put in a 5, a -3, a -5, and a 1/2, right? So we put in a 5, a -3, a 5, and a 1/2. And when we put in those values, we got out 93, 29, 93, and -6. So if you think about it, x is what we put in, and then what do we get out? We get out a y value, typically. So then the next question is, you could rewrite your expression as an equation where y, or any other variable, represents the result you get. So for example, we put them all into 4x squared minus 7, so we could just simply say, well, that's the equation y equals 4x squared minus 7. So now let's just go ahead and look at the box underneath all of this. The reason I had you do this was so I could get you then to be thinking about, okay, I just put in a bunch of numbers and then I got out a whole bunch more numbers. So what we put in is called our input or our domain. And that's the new vocabulary word for today, the domain. And when I put in something, that's often referred to as your x values. That's what you put in. The numbers that we got out are called our output, or in this case, it's called our range, not to be confused with a range where you subtract the largest from the smallest. When here we put domain and range in the same sentence, domain means x, range means y. So we use the equation to put in and see what comes out. We often refer to the equation as a function. Later in algebra, we're going to talk about functions like it's our job. So for this case, when we're expressing domain and range, there are 3 rules that we need to follow in this case. The very first rule is we need to put the numbers in order. So let's put that in there. Super simple. Put them in order. That's the first one. The next thing we need to remember is if there's a number that appears more than once, we don't need to list it more than once. So we list the numbers only once. And then the last thing that we do is we put our numbers in what we call set notation, which are these little squiggly line brackets, okay? So then the third thing is put numbers in set notation. Set notation. And set notation are brackets that look like this. I'll do them again. Just like that. Now, if you can't draw those brackets perfectly, that is totally fine. You could just even do like a little squiggly line, as long as they are not parentheses or straight line brackets like that, because those represent something different in algebra. They've got to be squiggly line brackets. Okay? So the next question on your paper is, what is the domain of the function, of the above function, and what is the range? So let's just go back and look up at the top. And remember, we got here 93, we got 29, we got 93 again, and then we got -6. And in the table, it looked like this. Well, I'm not going to draw the table again. You remember with it. You can see your table. So the function, the domain, is what we put in, right? And those are those numbers. Or we can even look up here. So my domain were all of those x values, 5, -3, -5, and 1/2. But when we write them, we need to put them in order. Typically we go from least to greatest. So the smallest number there is -5. Now I'm going to put my answer underneath just because with this silly pen it makes me write really big. You can fit yours on the line. So put your answer on the line. So I'm going to start by my little squiggly line bracket here. Okay, and -5 is my smallest number, so it's just -5. -3 is the next one, then 1/2, then 5. And so put that on the line, and that right there is your domain. Now the range is, well, what did I get out? Well, I got out, and if you're looking at your table, you got out those numbers, or we got out these 4 numbers. Now, one of the rules, we don't want to repeat numbers. 93 happened twice. All we have to do is list the numbers that appeared once. So in order, squiggly line brackets, we put -6, 29, 93, and that is called the range of the function. So now let's take a look at the next 3 problems. Functions can be shown in a graph, in ordered pairs, and then they can also be shown as what we call a mapping. And this last little guy right here, this is called a mapping. You don't need to write that down if you don't want to. I just want you to know. That's called a mapping. Now let's go ahead and take a look here at this first guy. Whoopsie, I'm going a little crazy with my tools here. This guy right here. We're going to take a look at that. Now if you look, this is my x-axis, which is my input, and this is my y-axis, which is my output. And we are looking at these dots. There are a couple little empty holes there. Ignore those. Those are not actually your ordered pairs. So we're going to look at these guys. When I ask you what my domain is you just have to look at the x-axis. So this dot hits at 1, it hits at 2, it hits at 3, and it hits at 5. So my domain, in this case, we're just going to write D equals, don't forget your squiggly line bracket, 1, 2, 3, and 5. All right, I've got my dog with me today. He's eating a doorstop, which I just went ahead and let him eat, and he's now drinking a whole bunch of water. So that's the noise in the background. Apologize for that. All right, so now the range. When we're looking at the range, we are now looking at the y-axis right here. Okay, so if you look, there's a point right here that hits at 1, point here, 2, then we go all the way up here. Yeah, it hits at 5 twice, but we only want to list it once. So my range is 1, 2, and 5. So here we go. We're just going to say R equals 1, 2, and 5. Done. All right, the next one. Domain and range of the next one. If you think you've got it, go ahead and stop the video, write it down, and then double check to see that you have it. But let's go ahead and take a look at it. So here, these are ordered pairs. You know ordered pairs, right? In an ordered pair, the first number is x, the second number is y. So here, these are all my x values. So when I go to write my domain, all I have to do is say D equals, and then what's the smallest number there? It's the -3. And then we've got 0. And then we have 1, 4, and then 6. So it's just 1, 4, 6, done. All right, then the range. Now the range is all my y values. We only have a 2. We only list it once, just like that. So we put in squiggly line brackets. Okay, now the next one, we'll go ahead and do right down here. Here, this is called a mapping. And what a mapping does is it is just telling us the first thing, these are your inputs. Here are your outputs. Now if you look, the arrows are telling you what happens. So if you look, when I put in 1, I get out 1. When I put in 2, I get out a 3, I get out a 4, and I get out a 5. Now down here, this 3, 4, and 5, there aren't arrows pointing anywhere, so that's not really part of the domain here. And over here with the 2, because there's nothing pointing to it, that's not part of the domain either. So here, all we're going to say is the domain, or sorry, this is the range. This right here is our domain. So we're going to say our domain is 1 and 2. So D equals squiggly line 1, 2. And that's it. We don't put 3, 4, and 5. And then my range is over on the right-hand side. That is 1, 3, 4, and 5. 1, 3, 4, and 5. The 2 is not being represented. It's the arrows that are representing the function. Now let's go ahead and take a look at the back. All right, let's go ahead now and just take a look at these top little problems. If you read, it says the problems on the left are exactly the same as the problems on the right, just in a different, fancier notation. So if you take a look at the left-hand side, all of these just say evaluate, right? It gives you a problem, and then it tells you when x equals a specific number, okay? So now if we just compare, there's supposed to be a minus sign there. I don't know why that's not there. Hopefully yours has a minus sign. It doesn't really matter if not. It's not a big deal. All right, so now evaluate this is the same as this. This is just a fancy notation. You may have never seen this before, and you may have never seen this before. This is called function notation. And you say this, f of x equals 4x minus 8. Find f of negative 5. It's basically just saying evaluate when x equals negative 5. It's just super fancy. So if you notice, all of these have a rule telling you what to plug in for x. There's the rule telling you what to plug in for x. Rule, plug that in for x. This is your rule, plug that in for x. Rule, that should say minus, plug that in for x. Okay? Rule, plug that in for x. So all the problems are asking you to evaluate the function given a specific x value. So let's now just take this first one. The way that we say this is the function of x is 4x minus 8. Or the short way is to just say f of x is 4x minus 8. The second part is read like this. Find the value of the function when x equals negative 5. Or find f of negative 5. That's it. So let's do it. This is how you would look at it. F of x equals 4x minus 8. Find f of negative 5. I'm going to just rewrite it and say, okay, I'm going to find f of negative 5. And I'm going to plug in the negative 5 in for x. And then I'm going to evaluate it, right? So then I'm going to do 4 times negative 5 is negative 20. And to save space, I'm just going to do negative 20 minus 8 is negative 28. So this side is negative 28. Over here on the left, we're just going to rewrite the f of 5 equals negative 28. All right? So basically, what I just put in was negative 5. What I got out was negative 28. So this fancy notation really is just to help us keep track of what we put into the function and what we get out. You don't have to write your answer as an ordered pair. I just want you to understand that this represents an ordered pair. So now that you've heard me say this, stop the video and try the problem below it. All right, so now I'm just going to read this. I want you to listen and look at your paper, see what you have. So here, how do you read the first part? There's two ways. You could say the function, that little f, is not a variable. It is saying this whole thing right here is called a function. And right now, we're just going to say functions are equations that can be graphed. It's more than that, but that's just what I'm going to say functions are right now. So these can be graphed. You can put something in and get something out. So the function of x is 5x squared. And that's what one thing you should say here. Or we could just say f of x equals 5x squared. And that's what we could write here, okay? So if you didn't write it, write it. I'm not writing it right now, saving time. Then how do you read the second part? You can say find f of negative 2, or I can say find the value of the function when x is negative 2, all right? So now, when you go to do it, I'll do this with you. You are putting that 2, you're putting that negative 2 right there in for x here and here. Now here, this is just a notation. That's all it's saying. I'm saying I'm going to put in negative 2, and then I'm going to do the work to see what I get out. So I'm going to do this. I'm just going to write f of negative 2 equals 5 times negative 2 squared. Now don't forget that negative 2 has to go in parentheses when you square it. Or you just could have written f of negative 2 is equal to 5 times 4. You could have started the problem that way if you wanted. And then you say f of negative 2 equals 20. Now on a quiz, I'm going to say use proper notation. Your final answer really shouldn't just say 20, it should say f of negative 2 equals 20. Just a reminder again, that is just the ordered pair, negative 2, 20. When x is negative 2, y is 20. Or when my input or domain is negative 2, my output or range is 20. All right, now flipping to the other side. So far, we've used f of x. F stands for function. However, sometimes you have more than one function that you're dealing with. So f is often used to denote function, but any letter can be used. So it's like the name of the function. So in the other one, the name of my function was f, and my input was x. So here, for example, I could say g of x equals x plus 5. So here I'm saying the name of the function is g, my input is called x. Here, h of x equals 4x, the input is called the function is called h, the input is called x, and the rule of the function is 4x. So over here, the rule of the function was x plus 5. All right? Now, the input doesn't always have to be called x. It could be called something else, like down here. This function is just saying, I'm calling this function j. So the j, not a variable, okay? The input is called what? N, good. And this part is the rule, all right? So now, let's see if you can repeat after me kind of silently or answer my questions in your head. All right, so this function is called f, the input is b, and the rule is negative b plus 3. It's really funny talking to a computer, because typically when I teach this, y'all would be repeating this. All right, so now, here we go. Evaluate the functions using the given value. So now if you look, I have this function, which is called g. This is the rule. The input is x, right? This function is called h, and mine looks super crazy, but I think yours looks right on your paper. It does. I'm looking at your paper. There are parentheses here, and that's squared. All right, and then this function is j. So now if you look, letter A says find h of negative 2. What am I asking you to do? I'm asking you to plug negative 2 right here, and do the problem. And here I'm going to go ahead and just write my parentheses. There's parentheses here, not a random strange division sign on the side. I don't know. And that's what that problem looks like. So you're putting the negative 2 in for x, and you're going through and doing the work. Okay? I'll do that one with you in just a second. And then the second question, g of negative 1 is asking you to put negative 1 into this function here. And this one, find j of negative 6, I'm asking you to put in negative 6 into this function here. All right, so now let's do the first one together. All right, so I've got h of negative 2. So I'm going to start with h of negative 2. I'm going to start by writing that first, okay? I'm now putting that into the h function. So I'm going to do my big parentheses, 5 times negative 2 plus 4 over negative 2, you do need to do negative 2 to the third power, plus 1. So the negative 2 has to go in parentheses on the bottom. It doesn't have to go in the parentheses in the top, okay? Then I'm going to square that. All right, now don't forget about all that. All right, so now let's write this again. H of negative 2 equals 5 times negative 2 at the top, right? We're going to go and do the top. 5 times negative 2 is negative 10, and negative 10 plus 4 is negative 6. All right, now the bottom. If I'm looking at the bottom, negative 2 to the third power. So negative 2 times negative 2 is positive 4, right? But then we have another negative 2, so now it becomes negative 8. So 4 times negative 2 is negative 8, and then negative 8 plus 1 is what? Negative 7. Very good. Now we have this whole thing is still in parentheses, and we're going to square this. All right? So now, first of all, this final answer is definitely going to be positive, no matter what. Right now, at the very beginning, if I look at this, a negative over a negative is a positive. Another thing, if I don't change this to a positive right now, we're still squaring the top and the bottom, right? Because 6/7, I'm just going to go ahead and rewrite this as h of negative 2 equals 6/7 squared because it's a little bit easier to know that. Like a negative over negative is a positive. And so then when I do 6/7 squared, don't freak out, that's just 6/7 times 6/7. So the final answer, and I'm running out of room over here. I don't think you will be though, but if you are, just write small. H of negative 2 equals 36 over 49. And that's it. That's our answer for that one. Okay? So now I want you to pause the video, and I want you to do B and D on your own. I have no idea why it says B and D and not B and C. But go ahead and do the next two on your own, and then tune back in, make sure you did it right. All right, you should have for B gotten J of negative 1 is equal to negative 1. I'm sorry, not J, G. And then the next one, J of negative 6 equals 1600. Now, I want to point something out with my work. If you noticed on the first problem, I kept rewriting h of x, h of negative 2, h of negative 2. If you notice, once you start doing these problems, if they take multiple steps, you get really tired of writing that. So I always get the question, can I just write it on at the end? And the answer is yes, but don't forget about it, right? So start it off, go ahead and do the problem, and then at the very end, if you just want to write J of negative 1 equals negative 1, that's totally fine. Same with over here, okay? I did it, I wrote it, I did my first step. Notice this is positive 36. I just did that in my head, negative 6 squared, because it was 6x squared, right? Plus 4, 40 squared is 1600, okay? Those are your correct answers. If you got it wrong, just look at my work, see if you can figure out where you went wrong. Let's go to number 2. And number 2. Number 2, you can use the function f of x equals 3 half x plus 40, where x represents how many questions you get right on a multiple choice portion of a test to compare your test grade. You scored a perfect 40 on the written section. Find your test grade if you get the given number of questions correct. So, yeah, it's a word problem, but that's okay. Even if you don't understand the word problem, you have the function and you have what it's telling you to do. So this is your function. It's saying find f of 40. You put 40 in for x. So I'll do the first one with you. So you're going to do f of 40 equals 3 over 2 times x. I'm going to go ahead and just write 40 over 1 right now so we don't get confused. Then plus 40. So now the cool thing, don't forget when you multiply fractions, you can cross cancel. So I'm going to say 2 goes into 40 20 times, right? 3 times 20 is 60. So I get 60 over 1, which is just 60, right? Plus 40 is 100. So when you get this, you get f of 40 equals 100. Stop the video, do the next two on your own. All right, so B and C. I got f of 32 equals 88, f of 20 equals 70. If you got it wrong, pause the video and just look at my work for a second, see what I did. All right, now the next question, number 3. In number 2, what is the domain? Well, remember, the domain is what we put into the expression. So for here, I put in 40, or you can even look here. We put in 40, I got out 100. I put in 32, I got out 88. I put in 20, I got out 70. So domain is what you put in, okay? So don't forget your brackets. I put in 30, I'm going to go in order. 20, 32, and 40. That's what I put in. Go ahead and put it on the line. All right, the range is what you got out. So we're going to just do our outputs, our final answers. So 70, 88, and 100. So it's just 70 in brackets, 88, and 100. Done. Okay, 2 more problems to do together, and then the back is your homework. So number 4. This is another way of phrasing a question, and lots of times people get a little bit confused by this question. So find the range of the function given the domain, negative 10, negative 3, 1, and this is f of a equals negative 3a squared plus 5. So basically what this is saying is the given domain. Well, domain, remember, is our input, and I've got 1, 2, 3 of them. So essentially what I'm asking you to do is put in negative 10 in for a, get an answer. That's your first range, or one of your ranges. Get negative 3, plug that in for a, get an answer. That's the other range, and then put 1 in for a, get an answer. See what you did. So I'll do the first one with you. All right, so I'm going to say f of negative 10 equals negative 3 times negative 10 squared. And if you want to do negative 10 squared in your head, which is 100, and write that down, you can, plus 5. Then I've got f of negative 10, again, is going to be negative 3 times 100 plus 5. So then I get negative 300 plus 5 is going to give me negative 295. So I'm going to get here f of negative 10 equals negative 295. Pause the video, do negative 3 and 1 on your own. So for f of negative 3, I got negative 22, and for f of 1, I got 2. If you didn't get that, pause the video, look at my work, look at your work, see if you can figure out what you did wrong. So now the next question is, give the range. Well, the range are the answers, what I got out. So for the range, don't forget, squiggly line bracket starts it off, and then we're going to put it in order. And my answers are already in order. Negative 295 is the smallest, then negative 22, and then 2. And then I've run out of room for my little squiggly bracket, but you put your squiggly bracket in there too. And my squiggly brackets have gotten really ugly towards the end of this. All right, pause the video and try number 5 completely 100% on your own and see if you can get it without my help. And here you go. So I got f of negative 4. Whoops, I forgot to write my f of negative 4. f of negative 4 equals 23. I got f of 0 equals 7, and I got f of 4 equals 23. So my range is 23 and 7, right? And I don't repeat the 23, and I should put it in order. So I'm going to say 7 and 23 is my range. And so on a quiz, when I say show work appropriately, what you see right here is pretty appropriate. It's like what I mean by appropriately. Don't forget your brackets, don't forget all the rules about putting stuff in order, and yada, yada, yada. So you should make sure that this whole packet is 100% complete. So if you skipped around on the video, go back or finish the problems on your own and get that back done. That's your homework. And I hope things are going well for you. Enjoy the rest of your day.